Like all of mathematics, or mostly all mathematics, linear algebra uses number systems or number fields. They use number, number systems, the oppressive system of numbers. That sucks. Anyways, and by number system or number field, we mean that any set K, so a set K, any set K of objects, these objects called numbers, of objects, any set K that has objects numbers, which are numbers, which when subjected to the four arithmetic operations give elements of K. So a number system is a set K that has objects which are numbers, right? So collection K that have objects which are numbers that whenever you apply for arithmetic operations like addition, subtraction, multiplication, division, you get another number that is in K. Or to be more precisely, a number field is any set K with numbers that they have to follow these certain rules. A, we're going to split these up into groups. A, for every pair of numbers, say alpha and beta, every pair of numbers, alpha and beta, in K, there corresponds a unique number. Unique meaning there isn't another number this found in this system. For example, like the 1, if we were to count from 0 to infinity, 1 would appear once. That would be unique. So there appears a unique number of alpha plus, this is a terrible alpha, plus beta in K. And that would be the sum of alpha and beta. So they're saying that for any number, two numbers in K, whenever you add them up, there needs to be another unique number in K that can be found in K whenever you add these two numbers up together. Okay? That's what they're saying. That's one rule. Another rule is that for whenever you add alpha and beta together, it has to be the same thing as beta plus alpha, as in the order you do it in doesn't matter. For that also to be considered a thing. And it has to be the same thing of whenever you take three numbers in K, and it goes alpha, let's say parentheses alpha plus beta plus gamma. That's the same thing as saying, let's say, alpha plus beta plus gamma. That's another rule it has to follow. So there's another rule. It's basically just going through different addition properties. There also has to exist number 0 in K such that 0 plus alpha would be equal to alpha. It's another property. So I should make this more. Give me a second. Okay, written down this 3. Okay, make it a little clearer. Another rule, next rule would be that 0, there exists a number 0 that when 0 plus alpha is equal to alpha. There you go. And the next addition rule would be that for every alpha in K, there exists a negative element, gamma, in K, that gamma plus alpha would equal to 0. That gamma plus alpha is equal to 0. So there has to be a negative version of alpha. Ow. Okay, the next set of rules is the product rules, the multiplication rules that basically say that for every pair of numbers in K, like alpha and beta, there corresponds a unique number that is alpha times beta that is in K. So basically just saying that alpha times beta, actually let's say this is A because this is a subgroup and it's basically just lining out this. So this would be a part of A. And we'll say B would be, okay, here's the next set. This goes over the multiplication, like the product stuff. So the whole gist of it is that alpha times beta is in K. Anyway, the product rules apply, which means that A times B, or alpha times beta, is the same thing as beta times alpha. This has to apply to the set, or it's not a number field. Second product rule is that alpha times beta times gamma is the same thing as alpha times beta times gamma. It's associative. So we have a commutative and an associative property. And the next one is that there exists 1 inside the number field. 1 times alpha is equal to alpha. That there exists that 1 inside the number field, that 1 times alpha is equal to alpha. Next is that gamma times alpha is equal to 1. Basically meaning that there's a reciprocal number, reciprocal as in the reciprocal of alpha would be, which is the same thing as alpha over 1 is 1 over alpha. 1 over alpha, which is gamma in this case. Gamma. Oh, I'm spoiling it. It's gamma. So, and alpha times 1 over alpha is just 1. And then the last thing is basically the distributive property, which is C, which is, the distributive property. Alpha times beta plus gamma is the same thing as alpha times beta plus alpha times gamma. Now, all these rules have to apply to every number in the number field, except for if it's not equal to 0. Like this one, alpha can't be equal to 0. What can be equal to 0 here? Because it's what? There's certain rules that don't apply to 0 because 0 is a little bit interesting. But this has to apply to all the numbers. All these rules. Otherwise, it's not a number field. And we'll go over number field in another video. But you can see some things that we're used to. It's not a number field. Some of the famous number fields, not famous, but well known, are, the ones that we come encounter with the most, so like the rational, the real numbers, and the complex numbers. But like things like integers by itself are not a number field because they don't satisfy certain things like this. Like an integer can have a reciprocal 1 over the integer. That'd be a rational number. Not all rational numbers are integers. But all integers are rational numbers. You know what I'm saying. Okay, but we're talking about number fields later, or number systems in another video. But yes, for it to be a number system, it has to follow all these rules. So yes, let's go.